Hello students, in the last session we completed 8 JEE sums. Those sums were mainly related to the differentiation and then the average velocity, right? And then some of the sums were oriented towards the graph, right? So we should be clear with all the 8 sums that we have seen. Same way in the session also I'm just hoping to complete 8 to 9 sums. These sums will also be related towards the graph and then the differentiation, okay, average stuff, finding the area under the graph and all those stuff, right? Okay. So that's what we are going to see in this session. I'm just hoping to complete like 8 to 9 some. Let's see how far we could actually do. Let's jump into the next question, which will be the ninth one. Here they have given you all the graphs below are intended to represent the same motion. Okay. So here, see, they have given you like 4 different options. And what they're telling us is the intention over here is all the graphs are going to have the same motion, but one of them does it incorrectly, but one of the motion is not correctly matched. Fine. So one of them is actually incorrectly matched. Pick it up. So I just have to get the one which is incorrectly representing that motion. Okay, so that's what I need to get over here. Okay, so first let me see the 4 different graphs. So one of the graphs should be wrong, so that should be my answer, right? So this is the 4 different graph over here. So the first one is actually the graph between the velocity and then the position. The next one is between the distance and then the time. Yeah, then you have got position, time, velocity, time. So this is how they have given us over here. So I hope so these two stuff seems to be related. Let me verify these 3 and 4. Then let us cross verify it with the first and then the second option. Okay, so if you look at the fourth option, this is pretty simple and straightforward, isn't it? What's happening over here? The velocity is decreasing. See, generally time graph will be easy for us to imagine. So position will be a little bit tricky. That's it. Okay, so when you look at the option 3 and 4, you here if you look at the option 4, you have got the velocity and then the time graph, isn't it? So here what is actually happening is you are having an object. Let's consider car over here. It is moving along the with the positive velocity. Okay, so it is moving at the positive velocity. Then what's happening over there is the velocity is slowly decreasing, and there comes a time point where the velocity becomes 0, and then the direction of the velocity gets reversed, which means it is moving backwards, right? So that's what's happening over here, right? The velocity was actually decreasing, there was a deceleration, braking was happening, and then there came a point where it braked and the velocity became 0, and then it started moving backwards. The velocity started increasing backwards. That's what happening over here. Let me verify this one with this graph. If it works out, then okay, fine. Then if it doesn't work out, then one of these two should be my answer, right? So let me verify it with the third option. So if you look at the third option, position and then the time, isn't it? So here, if you look at this option, initially the velocity was decreasing. Okay, so if it was an increasing one, then you could have got the parabola open upward. Yeah, because it has to increase. But in the situation, it is pretty clear. The velocity is decreasing, therefore it has to brake. There should come a point where it has to come to rest. That will be the maximum position. So it is obvious. It is moving forward. The velocity is decreasing, and there came a point where velocity becomes 0, and that was the maximum position, right? Then it started moving backwards. Yeah, it started moving backwards, and there came a point where it reached its initial position. That too is possible. Fine. So here 3 and 4 are actually supporting the direction of motion. So those two are same motion. Therefore 3 and 4 is correct. So that's not the incorrect over here. So now let me verify it with the distance time graph over here. Okay. So here if you look at this equation, so here what they've given us is here it's the distance and then the time. So obviously this is actually a scalar quantity. Okay, so you have to count all the distance that is covered in the same direction itself. So that's how we do the distance, isn't it? This is actually a scalar quantity. You have to be clear with the notion. I've already explained you in the theory. It should be obvious. So here if you look at this graph, yeah, it should be the velocity. What has happened to the velocity? The velocity was actually slowly decreasing, but here it seems the distance keep on increasing. So if it has to be in this fashion or parabola open upwards, then the velocity has to increase. But if you look at the situation, the velocity was not increasing, the velocity was actually decreasing. Therefore initially it should have covered more distance, then it will cover less distance. Okay, so it should look something like parabola open downwards. Same argument that I've made it over here. Okay, here it was like position time, here it was distance time. That's it, right? So here also it has to be like parabola open downwards, right? So this one is obviously the wrong incorrect statement, which has to be my answer. Okay, incorrect graph. So it has to be a parabola open, yeah, downwards. But here they have given you something like open upwards. That's not possible, because if it has to be a parabola open upwards, then the velocity has to keep on increasing. But in this situation, the velocity is reaching zero, right? And then what has happened to the velocity? It started, yeah, it started increasing in the backward direction. So when it is increasing in the backward direction, the direction doesn't matter. I have to count everything as the positive quantity itself. That's what is meant by distance, right? So even the negative direction has to be accounted as positive. So in that situation, the distance has to proportionally increase, right? First, the velocity was decreasing, therefore there came a point. Therefore, there came a point, the distance started dwindling down. Then there came a point where the velocity was increasing in the negative direction. In that position, it has to increase, right? Because the negative direction should also be added over there, right? Therefore, it has to increase. After this interval, the displacement has to proportionally increase. Okay, it shouldn't actually decrease. But if you look at this graph, the second part is also wrong, because it is actually reaching some saturation position. That's not going to happen over there. It has to keep on increasing, because I'm just increasing my velocity in the negative direction. Therefore here this shouldn't be in this fashion. The next part of the graph should be something like this one, right? So this is how it has to be, right? Okay, so instead it is the other way around. So this is the wrong answer over there, which has to be marked. So the answer over here is option 2. Let me verify the first one also over here. So if you look at the first one, they have given you between the velocity and then the position. So what has happened to the velocity? Obviously, with respect to the position, yeah, if you look at this one, with respect to the position, the velocity was decreasing, right? As it was moving forward, the velocity was decreasing. That same way, initially the velocity was maximum. As it was moving forward, the velocity was decreasing. Yeah, that's obvious. Then what has happened? There came a point when the velocity was zero at certain position. Then the velocity was actually increasing in the negative direction, right? So option 1 is also right. So this one has to be clear. Option 2 is my answer, right? Got it? I have to choose one of them does it incorrectly. So which of the option isn't matching with the motion? That's what I need to get over here, and I got it, which was option 2, right? You should be clear with this question. This is a graphical based sum. You shouldn't have any doubt in this question. Let's move to the next one. This sum is also graph based sum. Let me read the question. The velocity time graph of a car and a scooter are shown in the figure. Got it? So they have given you the graph for two different vehicles, which is car and then the scooter. Got it? So they've given us the velocity time graph. So velocity time graph is given. So what they're asking us to find is from the graph, the difference between the distance traveled by the car and the scooter in 15 seconds. So in the first 15 seconds. So if you look at the graph, the first interval is between 0 to 15 seconds. Where in this situation, the scooter has a constant velocity of 30 meter per second. Okay. But with the case of car, you are having an acceleration, therefore the velocity is increasing in linear fashion. Okay, so the difference between the distance traveled by the car and the scooter in the first 15 seconds, that's what I just need to get. So if you look at this one, it should be obvious. Yeah, the scooter would have traveled much more greater distance when compared to that of the car, right? Because it's actually half times this triangle. Yeah, just by looking at the triangle itself, just by looking at this picture itself, it should be obvious that this the distance covered by the scooter will be greater when compared to that of the car. Okay, so here they have given us just get me the distance. Yeah, so distance actually means you just have to get the subtracted quantity. That's it, finished. You do not want to worry about that negative sign, isn't it? So I just need to get the positive answer. Even if you look at this one option over there, everything is gonna be in positive. Therefore, yeah, I'll have to subtract. How will I actually subtract this? The distance covered by the scooter minus the distance covered by the car. Even if you do it in the other way around, you'll get the extra negative sign. That's it. The magnitude is just going to be the same one, right? Then what I need to find is the time at which the car will catch up with the scooter. Okay, so it should be obvious the scooter is ahead of the car, and there should come a point where this car catches up with the scooter, which means the area under the graph of the car will be equal to that of the area under graph of the scooter. Okay, so you should get the time where these two areas are going to be same, after which obviously the car is going to overtake the scooter because it is going to have more velocity when compared to that of the scooter. Okay, so this is what I need to get over here. So now first let me get the difference between the car and then the scooter in the first 15 seconds. Okay, so to get that one, first I just need to get the area under the graph for the scooter. Okay, so distance traveled by the scooter, yeah, in the first 15 seconds, isn't it? Distance traveled by the scooter in the first 15 seconds. Okay, I'm just doing it for the first 15 seconds, so that should be equal to, what should it be, length times the breadth. I mean the breadth over here is, or the length over here is like 30. Okay, 30 multiplied by 15, isn't it? Yeah, so 15 into 3 is going to be like 45, so that's going to be 450 meters. Okay, so this is done. So this is the distance traveled by the scooter. Next, to get the distance traveled by the car, I just need to use half times base into height, isn't it? So half times, what was the base, what was the height over there? It was like 45 multiplied by, yeah, multiplied by 15, isn't it? 15, that should give me the answer over there. So just let me cancel it over here. So if I do cancel this one, you would have got 14 is going to be 7.5, isn't it? Yes. So just do the multiplication of those two stuff, subtract it, you'll get the answer. So the multiplication over there will be 45 and then 75, 25, 2, 5 is at 20, yeah, 2, 2, 35, 3, 28, 31, right? Yeah, 31, yeah. 5, 7, 3, 3, yes. I just have to move one decimal place, therefore it should be 337.5. The answer over here is 337.5 meters. So now you have got like two different distance. As I've already told you, the distance traveled by the scooter will be greater when compared to that of the car, right? Yeah, that has to be obvious. So here they're just asking us to find the difference, by the way, the distance, right? So distance, it doesn't matter, the sign doesn't come into picture, therefore I'll have to put only the positive answer over there. So here it should be obvious, 450 subtracted from 337.5. Yeah, so the next thing is 450 337.5, right? So 4, 9, 10, that's gonna be 0.5, 7, this is like 2, this is like 1, 112.5. So 112.5 should be my answer. So that's the difference over there, 112.5 meter. Okay, so now I have got 112.5. Okay, so for now I have got the first one, which is either the answer could be 112.5 option 1, or else it could be like option 4. Those two stuff are possible, right? Next, what I need to verify is at what time those two stuff will catch up each other, car and then the scooter, right? That's what I need to get then for the next answer. Either it could be like 15 seconds, obviously that's not possible. Yeah, at 15 seconds, obviously that's not possible, because it should be clear there was difference between the distance, right? There was that difference, therefore the scooter was ahead of the car. That shouldn't be the time when the car is going to catch up with the scooter. So 15 seconds is not possible. So the answer should be option 4. Let me verify it, right? Anyway, I just found the answer over here. The answer is like option 4. Let me tell you how to solve for that one. So here with this case, I just need to generate an equation, then I'll have to solve it. So the equation that I'm going to get over here is something like this, which is, let me do it over here. So the equation that I need is, initially, yeah, the distance covered by the car, so that those two stuff are equal to each other, right? First, let me put it for the scooter. For the scooter, from the initial time to certain time where those two stuff are gonna get catch up with each other. In both those situations, it had the same constant velocity, right? So the velocity multiplied by the time will give you the answer. So the velocity was Yeah, the velocity multiplied by time, right? So velocity is distance by time. So velocity multiplied by time will give you the distance. Therefore, the velocity over there was 30. Yes, it should be obvious, multiplied by the time. So what should be the time? So the time is something that I need to get. So t is something that I need to get, right? Then what I need to know is what was the distance, what could be the distance that was covered by the car. So it should be this 337.5 meter plus some constant velocity that was equal to 45 multiplied by the leftover time. So that leftover time will be from that 15 seconds. Okay, so let me get the equation, you'll get it. So first I'll have to put this 337.5. Okay, this was the distance that it has covered. 337.5, yeah, 337.5. So this was the distance that it has already covered before reaching that constant velocity. So that constant velocity was equal to 45, isn't it? Yeah, and then now I'll have to multiply it with the time, relating with this time from the initial. Okay, so it has already crossed this 15 second. After that, okay, I'll have to account that time. Okay, so if it was like 20 seconds, I'll just have to multiply 5 over here, right? So 45 multiplied by 5. But here I do not know the time over there. Therefore, I'll have to get the time t, okay, comparing it with the initial condition, and then I'll have to subtract this 15 seconds. So that will give me the leftover time that was required so that this scooter and then the car has reached the same distance. Okay, logic should be clear. Therefore, 45 multiplied by that time. So that time after 15 seconds. So I'll have to subtract that 15 from that initial time. Okay, from that 0. From the time that was measured from the initial condition. Got it? So here it should be something like this: 45 multiplied by t minus 15, because we know until 15 seconds it has already crossed this 337.5 distance. Okay, so that has been added. So only thing that is left is I'll have to get the leftover distance so that the distance traveled by the scooter and then the car get matched. That's what I need to get over there. Therefore, this is the equation that you should generate. Now it should be clear. Just do the rearrangement and solve this equation. You'll end up getting the answer. That's it. Okay, so now just let me do the inner multiplication over here. So if I have to do the inner multiplication, what should it be? So here it's going to be 337.5. That's obvious. 45t. Okay, then it should be like 45 multiplied by 15. So let me do the multiplication of 45 multiplied by 15. So that's going to be 45, 15, 25 to 20 to 2. Yes, this is like 45. That's right there. 5, 7, and then this is like 6. So that's 675. Okay, now I've generated the equation. Let me substitute it over there. If I do substitute that one, you would have got 337.5 plus 45t. That's the inner multiplication that I have done over there, subtracted from minus 675, which will be equal to 30t. Okay, so now if I do the rearrangement, this 30t, if it comes to the left hand side, that becomes negative. Therefore you will have like 15t. Okay, so you would have got 15t, which will be equal to 675 minus 337.5, isn't it? 675 minus 337.5. Let me subtract those two stuffs. 675 minus 337.5. Okay, yes, that has to be correct. So you should have got 0.5. This would have been like 4. Yeah, 6, 14. So that's going to be 7, 6, 3. So again, you would have got like 337.5. That was actually, yeah, half time that one, isn't it? Yeah. Okay. So here it should be 15t, which should be equal to 337.5. Okay. Just do the division of these two stuff. We'll end up getting the answer. So t will be equal to 337.5 divided by 15. Okay. Now just if I take the division, I'll get the answer, right? So let me do the division straight away. You would have got 337.5 divided by 15. Okay, so for the first one it has to be 30, so that's going to be 2. Yeah, obviously that's matching. So then you would have got like 37. So even for that one you would have got one more 2, so 22 point, yeah, right. So that's going to be 337, 3375, isn't it? So 15 times 5 is going to be 375. Yeah, that's it. Yeah, somewhere around 5 4, that should be my answer. So 22.5 second, 22.5 second was the time when both the car and the scooter caught up with each other. Okay, the answer over here is option 4. It should be clear, you shouldn't have any doubt on this question. Okay, so here what we did is, first we just found the difference between the distance of those two vehicles. Okay, so to get that one, just find the area under the graph, subtract the higher value from the lower value, you'll get the difference over there. Okay, so that stuff is done. Okay, next what I need to get is, I just need to get the time at which both those car and then the scooter is going to catch up with each other. So to get that one, first I'll have to generate the equation. So to generate that equation, I just know initially the car was lagging behind that of the scooter. Okay, so that first triangle, just get the area straight away and put it over there. Then for the leftover time, what you should do is, you'll have to get that total time t and then subtract it for the first 15 seconds. Okay, so if you do that subtraction, only the leftover time will be multiplied with the constant velocity. That was like 45 meter per second for the car, right? So now the left hand side of the equation got generated. That was an easy one. Same way for the right hand side, that is like super easy. So which is going to be the constant velocity multiplied by the time, right? So now you have got the fully needed equation. Just do the solving, you'll end up getting the time, the required time that was needed, right? So it was 22.5 seconds. Got it? You shouldn't have any doubt in this question. It has to be clear. Let's move on to the next one. This question is a little bit tricky. Let me read the question. Here you've got, a man in a car at location Q on a straight highway is moving with speed V. Okay, so you're having a guy who is in the car, and then he is moving in the straight highway, okay, with the speed V. The velocity of this car was equal to V. Fine, so that's the first statement. Then they're given us, he decides to reach a point P in a field at a distance D from the highway. So he just wanna reach a point P which is in the field. So this area is actually a farm field area, something of that sort. Okay, so this is muddy or sandy, whatever it is. Okay, he decided to reach a point P in a field at a distance D from a highway. Yeah, highway which is at a point M as shown in the figure. Okay, so this point P is actually perpendicular from the point M in the highway, and the distance between the P and the M was equal to D. That's what they've given over here. So he just decides to reach the point P in a field at a distance D from a highway as shown in the figure. So this is actually a perpendicular distance, right? So that's obvious. Okay, speed of the car in the field is half to that on the highway. So when he's about to drive the car on the field, its velocity will be half. Okay, so the situation is not favorable, therefore the speed of the car was half that of the speed of the car in the highway. Okay, so speed of the car in the field is half to that on the highway. What they're asking us to find is, what should be the distance RM. So at what point on the highway he should make that inclination towards the point P in the field, so that the time taken to reach P is minimum, so that the time is going to be minimum. Either he could move from this Q itself, he could move straight to that point P from the field. Obviously that's going to take more time because the velocity in the form was half, right? Or else he could move straight to the point M and then he could move perpendicular. That too is going to be more distance. That too is going to take more time, right? So it has to be obvious, but there should be a minimum suitable position from which, if he's going to take a if he's going to take a turn and then he's going to move towards that point B, that could possibly give me the lowest time. Okay, so I should get that lowest time. So to get that lowest time, obviously this is a kind of minimum or maximum situation, therefore this situation is pretty obvious, this is going to be the minimum position, right? So whatever the case it is, if I have to get the minimum or maximum position, first I need to get an equation, right? So once you get the required equation, just differentiate that equation and then equate it to 0. Here, how should the relation be? Obviously what they're asking us to find is the time. Okay, so time should be along the y-axis, right? So time should be along the y-axis because that's the minimum stuff that I'm going to find. Okay, so generally when you are going to get the minimum position, how would I actually do? Along the y-axis you'll have like y, along the x you got the x, and then you're going to have the graph. You'll get the graph something like this, y equals x square. Okay, when you are about to differentiate this one, dy by dx equal to 0, Okay, when I'm going to differentiate this one and equate it to 0, I'll get the minimum position for the y. Here, the minimum position which I need to get is for the time. Therefore, time should be plotted along the y-axis. That's done. Then what should be along the x-axis? The distance should be along the x-axis. Okay, so the combination of this distance and this distance should be along the y-axis, right? So now I just need to get the combination of this distance and then this one, right? Okay, so when you look at this one, it should be pretty obvious. By the way, what they're asking us to find is what should be the distance or m. Okay, so I just need to get the distance or m. Okay, so this distance, what should be it, so that the time has to be minimum, right? So I just need to get the minimum time, okay, for the distance where I should actually make the turn. Okay, so that distance is actually this rm distance. Okay, so first let me give an variable for this one. So let me consider this small distance to be x. Okay, this distance where I'm going to make the turn is going to be x. So if this distance was x, then obviously this is a right angle triangle, which means this is hypotenuse side, so that should be equal to, so this one should be equal to root of r square plus, no, d square plus x square, right? So this distance has to be d square plus x square. Okay, so now I have got the distance rp. So this distance has to be d square plus x square. So based on the position where I'm going to make the turn towards the field, this x is going to vary. Okay, so this is actually a variable parameter which will depend on this x. Okay, so this is the x that I plotted along the x-axis, isn't it? So based on the x that I'm going to choose, you'll get like different time. Okay, so I just need to get the lowest time for the given x. Okay, so the logic should be clear. Okay, so let me draw the graph. So here you would have got x along the x-axis, same way time t along the y-axis, right? If I had made turn very close to q, I would have traveled more distance along the form. Okay, so if I had taken turn very quick, then the x will be less. Obviously, the time will be greater. Okay, something like this at this position. Then, if I had taken x very close to the optimal value, that time is going to be less when compared to this one. Then there will come a point where that will be the optimal time where you have got the lowest, lowest time taken. Okay, then if you just go more close to this m, then obviously you're going to travel more distance. This perpendicular distance is going to dominate when compared to that of this one and the combination of this one. Therefore you are going to take more time. Okay, so there will come a point, if you are going to take very less amount of x, that too will give you more time taken to reach the form field. Okay, so that this optimal position t is something that I need to find. So obviously t will be along the y-axis, x will be along the x-axis. So I just need to get the combination between the relation between the equation t and then the x. Okay, for the equation t and then the x. Got it. So to get that one, first I'll have to fix this hypotenuse side. So the hypotenuse side will be d square plus x square. X, yeah, I just need the term because that should be along the x-axis, for which I'm going to differentiate. Okay, I'm going to use that one to differentiate, right? So this stuff has to be clear. Then obviously QR is the distance traveled along the highway, right? So if I have to get that stuff, the total, let me put it this way, I can't put like one more variable to this one, so that's not possible because this one will also vary according to this to that of this x, but I know this qm is going to be constant, right? So let me consider this total distance to be d along the highway with respect to this point p position perpendicularly. Therefore if this total distance was like d, okay, if this total distance was like d, then what should be this interval q, or it has to be equal to that of d capital D minus x, right? Obviously this one has to be equal to d minus x, right? Now I have got this distance that the vehicle has traveled in that highway, so that one is also done. Now I'm just ready to find the equation for the time and then the distance. Okay, from which I'll get the optimal distance where I have to make the turn, so that I'm just going to have the lowest time in that situation. Got it? Yeah, it has to be clear. Now let me generate the equation. If I have to generate the equation, left hand side is obviously going to be the time t, like that of the y. then what should be on the right hand side? Accordingly, you should match it with the distance. Okay, I just know velocity equals speed equals distance divided by the time. Okay, here they have given us clearly the speed on the highway was equal to v. Yeah, right. So speed on the highway was equal to v, but in the case of that form, it has to be half that of the speed, which means that's going to be v divided by 2. Okay, so now I just know the speed. So speed divided by, yeah, velocity equals distance divided by the time. Yeah, then what should be the time should be equal to distance divided by the velocity. Okay, so in the numerator I just need to have the distance. Either it could be d minus x or d square plus x square depending on the form field or the highway. In the denominator I just need to put the velocity. Okay, so that will give me the combination of the time. Okay, so here in this situation, let me consider the time taken by the car that it has driven on the highway will be equal to t1. Therefore here you would have got t, which will be equal to t1. That was the distance traveled by the car on the highway. Same way, the distance traveled by the car on the form will be the time taken for the distance traveled by the car on the form field will be equal to that of t2. So t1 plus t2. Okay, so now let me replace this t1 with the distance divided by velocity. Okay, so that's going to be t, which will be equal to, what was the distance over there? It was equal to, yeah, d minus x for the first condition. See, where d is actually a constant, divided by the velocity. What was the velocity? Initially the velocity on the highway was equal to capital V, but in the case of form field, the velocity was v divided by 2. What was the distance over there? It was actually root of small d square, right? Small d square plus x square, right? So if I just differentiate this one and equate it to 0, I'll get the minimum time, okay, to reach p. That would have been got. So now let me differentiate this one and equate it to 0. So dt divided by dx has to be 0. So if I have to differentiate the above equation, how would I actually be able to differentiate this one? So dt by dx, yes, it has to be equal to 0. So you have got like d minus x divided by v, isn't it? If you split this into two fractions, what would be there? D by v minus x by v. That's what you would have got. What will be like d by v? D is also constant, v is also constant. Therefore, the first term goes to 0. Yeah, so the first term is going to be 0. Next, if you have to differentiate this one, minus x divided by v. Obviously, v is a constant one. I'm differentiating it with x, therefore that has to go to 1 because it's just raised to 1, right? Therefore, you would have got minus 1 by v. You have to be clear with the differentiation. So you would have got negative 1 divided by v. Then with this one, yeah, with this differentiation, what would I have got? Yes, so here you would have got 2, yes, divided by v. Let me take that constant. Here I have to differentiate this entire term, considering it to be a single term, which is like d square plus x square. That has to be considered as a single term. So if you do the differentiation of that one, that will be equal to 1 more half, right? Power 1 by 2. Therefore, n x power n minus 1. So you would have got like half x power n minus 1. That would have given you minus half in the power. So this entire term will go to the denominator. You should be clear with the differentiation that I'm doing over here. So you would have got multiplied by half, okay, and then this would have come to the denominator, which would be t square plus x square. I've told you this is a kind of chain rule. Therefore here I've considered this entire term to be a single term. Then I'll have to differentiate this one more time, and I'll have to multiply it, right? If I do differentiate this term that is inside the root one more time, that would have given us d square. That's constant, so that's done. If you differentiate 2x, that x square, that's going to be like 2x, okay? So you have to multiply one more 2x in the numerator, fine? You should be clear with the differentiation that I'm doing over here. Yeah, you shouldn't have any doubt on that part. So now the differentiation is done. Yeah, so this part I have differentiated it, and then I have got this answer, okay? Yeah, just rearrange it, you'll get the answer. That's it, finished. Yeah, just do the rearrangement stuff. B will get cancelled out. Just the rearrangement will give you the relation between the x and then the d. Now, just the rearranging rearrange will give you the answer between relation between the x and then the d. Okay, so that's what they're asking us to find. Okay, so at what x I have to make this turn. Okay, so that will be related in terms of d. So if d was equal to 5 meter, d by 2 at 2.5 meter, x ahead of this m, I'll have to make the turn, inclination turn towards the point b. That's how it's going to get related. Okay, so now I have generated the equation. Just solve this one, you'll get the answer. So here it's going to be 1 by v, which will be equal to 2 divided by v. Yeah, let me cancel this one. If I to cancel these two, I'll just be left with 2x by v. Okay, so you would have got 2x divided by v multiplied by 1 divided by root of d square plus x square. Okay, let me cancel this v. Fine, just rearrange this one, equate it. I just need to get the x in terms of d, isn't it? Just rearrange it, you'll get the answer. If I have to rearrange this one goes to the numerator, which will be like d square plus x square. That has to be equal to, I have squared it on the left hand side and on the right hand side, so I would have got 4x square. Okay, if this goes to the right hand side, you would have got 3x square. That's going to be d square, isn't it? Therefore here x will be equal to d divided by root 3. So d divided by root 3 will give you the required x over there. Fine, so x will be equal to d divided by root 3, which will be option 2 in this situation, right? You should be clear with this one. You shouldn't have any doubt of this question. Fine. So the only tricky part over here is to generate the equation. So how should you actually generate? That's what you need to get. Okay, here they are asking us to find the minimum time to reach P. Okay, so time is something that has to be minimum. If I have to get the minimum y, then y will be along the y-axis, right? So that's how I'll do the differentiation. Same way in the situation also, time has to be along the y-axis. So that is done. Then what should be along the x-axis? At what x I just need to make that turn so that I'm gonna reach the P at the minimum time. Okay, so at what x I just need to make that turn, so that x is the rm that they've given in the question. Okay, so then therefore x or rm should be along the x-axis, right? So now I've just found out in what pattern that graph has to be related. So that stuff is done. Next, what I need to get is the relation between the time and then the x. So if I have to get the relation between time and then x, that's easy, because velocity, I mean distance divided by the speed will give you the time in the highway plus along the path in the form. Okay, so if you just add those two time, we'll end up getting the total time, right? That total time has to be lowest in that given condition. If that has to be the case, just differentiate it, equate it to 0. You'll end up getting a relation that relates between the d and then the x. Okay, so then you get the answer, which is going to be like d divided by root 3, right? It should be clear. Yeah, a little bit tricky, lengthy sum. You shouldn't have any doubt in this question. Let's move on to the next one. This sum is based on integration. Let me read the question. An object moving with a speed 6.25 meter per second is decelerated at the rate given by dv by dt, which is equal to negative 2.5 root v. Okay, so there was an object that was having an initial velocity 6.25 meter per second, and you're going to have a deceleration. So the deceleration actually means negative acceleration. Therefore you will have this negative sign here. If you look at the left hand side, it is dv by dt, which is acceleration, so a will be equal to negative 2.5 root v, right? Where v is the instantaneous speed, so they have given us the instantaneous. So where v is the instantaneous speed, obviously what I'm supposed to find over here is the time taken by the object to come to the rest would be. Okay, so what time this is going to get come to the rest, that's what I need to get. Okay, so if I have to get that one, I just know the initial velocity was 6.25, the final velocity will be 0 because it has to come to rest. Okay, so I just know if I have to integrate this equation with respect to velocity, the initial will be 6.25, the final will be, yeah, the final will be 0. And then on the right hand side, if I do the cross multiplication, you would have got the dt on the right hand side. So I'll have to integrate with respect to the time. So if I have to do the integration, that will be from the time 0 to the time t. With that time t is something that I need to find, right? So they have given you the equation straight away. Just do the rearrangement, bring one variable to the left hand side and the other variable on the right hand side. On the left hand side, you would have got velocity. Same way on the right hand side, you would have got the time. Just do the integration with respect to those differentials. If you do the integration, you'll end up getting the time. That's it, finished. Simple sum. Yeah. Let me write the rearranged differential equation that's needed over here, which is dv, that will be equal to negative 2.5. Same, we would have got the root v here, negative 2.5 dt, isn't it? Yeah, this stuff is done. Now I just need to do the integration, applying the limits. How should the limits be there? It should be 6.25. That would be the initial velocity, and then it will go to 0. Okay, same way if you look over here, the initial time is obviously 0, the final time is t. Okay, just do the integration, you'll get the answer. This is negative 2.5, isn't it? I find a mistake. This is going to be minus 2.5. Okay, so what will be the integration for root 1 by root v? So I just know it is v power minus 1 by 2. So what's the formula for x power n, integration of x power n? That's going to be x power n plus 1 divided by n plus 1, isn't it? So what is it going to be for x power n plus 1? So v, so let me put the bracket over here. So that's going to be v power minus 1 by 2 plus 1. So minus 1 by 2 plus 1 will give you like half divided by n plus 1, right? So that 2 is going to be the same half, which will be in the denominator. Okay, half. Okay, and then just 6.25 the limit 0, which will give you negative 2.5. Yeah, here if I do the integration of dt, that's going to be t, and the limit will be from t to 0 to t. Okay, so it is done. Just apply the limits. Yeah, apply the limit, you'll get the answer. That's it, t, and then some number that will give you the required time at which that object is going to come to rest. Okay, so just let me apply the limits. If I do apply the upper limit, that's going to be 0, so just leave that one. 0 minus of the lower limit, that's 2. So this you would have got like half, which will come to the numerator, so that will give you 2. 2 times v power 1 by 2, isn't it? So v power 1 by 2, so that's going to be 6.25 center root. So this is going to give you, yeah, 6.25 and the center root, isn't it? So 25 times 25 is going to be 6.625, isn't it? Yeah, that will work out. Negative 2.5. Also, you would have to use like long division method, but 25 times 25 is going to be 6.25. So that should be obvious. So upper limit minus lower limit, which will give you t. Yeah, now I have integrated this one, so you'll get the t over there. I have told you, right, this is deceleration, therefore you would have got extra negative sign into it. Those two negative sign will become positive, as I'm just finding the time over there. Time will always be positive, so t will be equal to 2. Yeah, I just need to take this one. Yeah, 2.5 multiplied by 2.5 will give you, so 25 multiplied by 25 is going to be 6.25. But if you look over here, that's 6.25. Therefore 2.5 multiplied by 2.5 will give you 6.25. So the root over there is 2.5. If not, you'll have to use like long division method. Anyway, we just know it straight away, therefore I just plugged in 2.5 over here. Yeah, that's going to be the square root for this one divided by 2.5. So the answer over here is 2 seconds. 2 seconds will be my answer. Okay, 2 seconds is the answer, which is option 2 over there. Yeah, 2 seconds was the answer over here. You shouldn't have any doubt on this question. It has to be clear. Just rearrange the equation and do the integration. You'll get the answer, right? Simple, easy one. Let's move on to the next one. This question is based on differentiation. Let me read the question. By the way, this is also a numerical type question, which means you will have a column where you'll have to fill the answer. So this JEE is actually computer based test, right? Therefore, you have to solve this one, get the number, and then fill it in the blank that they have given in the computer. Okay, so that's what you need to do. Okay, so this is numerical type question, so you wouldn't have any options to it. Let me read the question. Here you've got a particle moves in a straight line so that its displacement x at any time t is given by. So that is a particle which is moving along a straight line, one dimensional motion, and then they have given you the equation, which is x squared, that's equal to 1 plus t squared. So they have given you the equation. What they are asking us to find is its acceleration at any time t is x power minus 1. Okay, so I have to get the relation between the acceleration and then the x to the power something, okay, where n is. So I need to get the value for n. Okay, so whatever value that you get, you have to type it on the keyboard. Okay, so this is numerical type question. Got it? So first, they've given you certain equation. Let me differentiate this one. I'll end up getting the first equation that will give me the relation for the velocity. Next, if I do differentiate it one more time, I'll get the equation for the acceleration, right? So from that acceleration, I have to relate it such that I get the relation between the acceleration and then the displacement x over there, right? First, let me write the equation that they have given in the question, which is x squared. That will be equal to 1 plus t square, right? If I do differentiate this equation, you would have got 2x, okay, dx divided by dt. That's how it's gonna be. Okay, I'm differentiating it with respect to time. So on the right hand side, 1 is a constant, therefore it goes to 0. T square, that will give you 2t. Yeah, dt by dt, that one is 1. So do not want to worry about that one. So just let me cancel out this 2. So if you cancel out this one, 2 will get cancelled out. Therefore, you would have got x multiplied by the velocity v, which will give you t. Okay. So now you have got like two different relation between x and then the v. So here I'm just going to differentiate this one more time to get the relation between acceleration v. Okay. So if I have to differentiate this one more time, what would I get? Here x and v, these two stuff are, if you look at this one, x and v are actually related. Okay, both are variable because v in itself is dx by dt. If I'm going to differentiate it one more time, it's just the double differentiation of the x. I've already explained you. Therefore here I'll have to use the uv method. So what is uv method? uv dash plus v u dash. That's how you do the differentiation for two different variables which are on the multiplication. Got it? So for the x you would have got, x, okay, u v dash dv divided by dt, that is nothing but the acceleration, plus v u dash v dx by dt is again the velocity, so that will give you v square, okay, which will be equal to t. Here I'm going to differentiate this one with respect to time, so that's going to give you 1. Okay, so it has to be clear. Just rearrange this one. You will get the relation between a, v and x. So I'll rearrange it such that a is on the left hand side and then v and the x is on the right hand side. Okay, next what I have to do is I'll have to replace this b in terms of x and then the t. Okay, so then you will get a relation that's going to relate between a, x, t, right? I have to get rid of this t also. For that I'll use the first equation that they've given. So once I replace it and substitute this t in terms of x, obviously there will be a relation between a and then the x. Once you get that equation, I'll be able to relate acceleration and then the x power n, x power minus 1. Okay, so you'll get the relation. From that I'll be able to generate what will be the n, the required n that I need to get, right? Okay, so let me solve it. You'll get it. Anyway, first let me rearrange this one. So the equation that I need to solve this one is the first equation that I've given in the question. Same way, the first differentiated equation. Then the second differentiated equation, I have to rearrange it. If I do rearrange that one, I'll get a, which will be equal to 1 minus v square. Yeah, a equals 1 minus v square divided by x. Okay, for the v, I have to substitute this one. V equals t divided by x, isn't it? So you would have got 1 minus t square divided by x square divided by x. Okay, so this gives me the relation between a, t, x. Okay, this one has to be clear. Then if I have to get rid of this t, I have to substitute this one. T square equals 1 x square minus 1. Okay, if I substitute that one, then obviously on the right hand side everything will be in terms of x. Then just do the solving, you'll get the answer. Fine. So before substituting that one, let me rearrange this one. If I rearrange this, you would have got x square minus t square divided by x cube, right? So if you look at the above equation, it was x square which was equal to 1 plus t square. Okay, so directly I would be able to substitute 1, isn't it? X square minus t square is equal to 1. Same way here, if you look at this equation, it is x square minus d square. So this entire term has to be equal to 1. So here you would have got 1 divided by x cube, right? So a will be equal to x power minus 3. Now I have got the relation between a and then the x. So the power over there was minus 3. If you look at this question, it is x power minus n. So n should be equal to 3. Okay, because it is like minus 3. They have already given in the question negative n. Therefore, n should be equal to 3. So the answer that you need to type on your keyboard will be 3. Got it? It has to be clear. Simple sum. Just do the double differentiation of the equation that they have given. Rearrange it accordingly. You will end up getting the n that was needed for the question. Okay. It should be clear. Let's move to the next one. This question is based on average velocity. Let me read the question. You have got a horse rider covers half the distance with speed 5 meter per second. Got it? So he's going to cover the first half of the distance with the speed of 5 meter per second. Then the remaining part of the distance was traveled with speed 10 meter per second for half the time. Got it? So in the first condition, the distance was half. In the second statement, to cover the second distance, what he did was he had like two different velocity. The first velocity was 10 meter per second, and with that velocity, he had traveled half of the time. Okay, for the second interval. Got it? Once I draw the diagram, you'll get it pretty more clearly. And with the speed 15 meter per second for other half of the time. So first half of the time, he traveled with the speed of 10 meter per second, and in the second half of the time, of the second part that he has to cover, he traveled with the speed of 15 meter per second. Got it? So the statement is done. Then you have got the mean speed of the rider averaged over the whole time of the motion is x by 7. So they have given you the mean speed, which means I just need to get the average speed. If I have to get the final answer, that will be in this pattern, which is like x divided by 7. Got it? So what I need to get over here is the value of x's. So this is also a numerical type question. Fine, so you'll get some value over here. You'll have to divide, you will get this fraction, something like that, 40 by 7, 30 by 7, 35 by 7, whatever it is. And then you have to get that x. X could be 35, 45, 42, whatever it is, right? So I just need to get that x. Once you get that one, you'll have to type it in this blank that they have given in the question, in the examination. Fine, so let me solve this numerical type question. Let me draw the diagram for the condition over here. So here they have given you have got like the total distance. Yeah, this is the total distance. Let me split this one into two half. Okay, so this will be the first part and this will be the second part. So this is d by 2 and this one is d by 2. Yeah, it should be obvious. Got it? In the first interval, he has traveled with the speed of 5 meter per second. In the second part, he has traveled with two different speed, and the speed was connected to the time. Got it? For the first half of the time, he traveled with certain speed, and for the second half of the time, he traveled with the some other speed which was 15 meter per second. So first I'll have to get the average velocity for this interval. Then obviously to get the total average velocity, I know total displacement divided by the total time will get you the answer. Got it? So one is based on average, one of the average is based on the displacement and the other average is based on the time. Okay, once I do it, I'll get it. Yeah, it's a simple one. Let me put the velocity over there. So first, for the first one, you have got the velocity that was equal to 5 meter per second. In the second interval, I just split it into two half based on the time. So for the first one, this should be like t by 2. For yeah, the total time to cover the second displacement d by 2 was equal to total time t. That was split into two part, which was t by 2 and then the t by 2. You should obviously know in the during the first t by 2, okay, the velocity was less. Got it? Therefore, it should have covered less distance. During the second t by 2, it should have covered more distance because the velocity was greater. Here in this situation, the time was same. I just know distance is nothing but velocity multiplied by t by 2, isn't it? When you do multiply these two stuff for the first interval, the velocity would have been, to get the distance, velocity multiplied by t by 2. Therefore, in the first interval, the velocity was less, but the time was same with respect to both those cases. Therefore, obviously, the distance covered in the first of the second part is going to be less when compared to the second distance that got covered in the second part. Okay, the logic should be clear. First, let me find the average for this one. Once I get the average velocity for this one, I just know I can find it for the average velocity for this entire motion. Okay, so the average for this one is also simple. easy straight away one. So if I have to get the V dash average, something like that, what should it be? Average is nothing but the total distance covered divided by the total time taken. Got it? So here in this situation, the total time taken is nothing but the t. That's the total time taken over there. Then what would be the total distance covered? Yeah, the total distance covered is nothing but velocity multiplied by the time. What was the velocity initially? Initially, the velocity was 10 meter per second for the first part. Okay, 10 multiplied by the time, that's going to be t by 2. So this will give me the distance covered in the first part. That's going to be less, plus the distance covered in the second time interval, which was also the same one. So you would have got 15 multiplied by t by 2. Okay, when you look at this one, it should be obvious. T was, if you factor out t, that will get cancelled out, isn't it? T was same. So here v dash average would be equal to 10 plus 15 divided by 2. Yeah, that's going to be 25 divided by 2, isn't it? Yeah, 25 divided by 2. So this is the average velocity with respect to the second part. Got it? So this stuff is done. Therefore, I can just put it over here, which is V average for the second half of the distance will be equal to 25 divided by 2. Now I'm supposed to get the average velocity for this entire motion. So if I have to get the average velocity for this entire motion, same logic, same thing. This is something that we have already done, isn't it? So to get this one, same way, total displacement divided by the time taken. Here in this situation, I just know displacement is going to be constant, time will be different, right? Therefore, V average will be equal to, yeah, you would have got the total displacement to be like D divided by, yes. Here, I just need to substitute the time. In the situation, the time would get cancelled because I just know it is in some fraction with respect to the total time. But here in the situation, this distance is something that I could compare. Therefore, how should I do is, I'll have to replace the time by velocity divided by the displacement. No, displace time with displacement divided by the velocity, isn't it? So the d over there is d by 2 for the first part. And what should be its velocity? It has to be 5. D by 2 divided by 5. That should give me the first velocity. And for the second one, it should be, yeah, the second part was like d by 2 and then divided by 25 divided by 2. Yeah, it should be clear, right? You shouldn't have any doubt. Yes, you just solve this one, you'll end up getting the answer. That's it, finished. Let me factor out d over there. That will get cancelled. So d will get cancelled. Then you're just left with this fraction which I need to solve. That will give you 1 divided by 2 by 5. No. 1 divided by, that's d by 2, isn't it? Therefore, it should be like 1 by 10 plus here, that's going to be 1 divided by 25 into 2, and then there will be a 2 in the numerator. So these two stuff will get cancelled out. 2 will get cancelled out. Just cross multiply and flip it, you'll get the answer. If you have to do the cross multiplication, you would have got 25 plus, that would have been 25 plus 10, 1 divided by 25 plus 10, that's going to be 35, isn't it? Divided by 250. Yeah, that's right, divided by 250. So that should have been 250 divided by 35. They're asking us to find such that the fraction should have 7 in the denominator, right? If you need to have 7 in the denominator, I just know like 7 multiplied by 5 is going to be, yeah, 35. Therefore, here I'll have to cancel in the multiples of 5. So this will give you 7. This is going to be 50. So the answer over here is 50. You'll have to type 50 in the blank. Therefore, the answer is 50, right? You shouldn't have any doubt on this question. In this question, I'm just going to take average based on two things. One is based on the time, So in the second part of the motion, time was something that I know. Okay, it had like say it took same time interval if I'm going to split it, which was like t by 2 and t by 2. Therefore, from that I found the average velocity for the second part. With respect to the first part, that is something that we have already done, which is like total displacement divided by the total time. In that total time, I should replace in terms of velocity divided, I mean displacement divided by the velocity, right? Once you plug in all those values, we'll end up getting the answer. That's it. Simple sum. Yeah, right. You shouldn't have any doubt on this question. Let's move to the next one. This question is kind of match the following sum. Let me read the question. You have got match column 1 with column 2, right? So I just have to match these two graphs and which one is going to be correct. That's what I need to get. So here, if you just look at the statement over here, choose the correct answer from the options given below. So I have to get the correct options for something that they have given over here, right? So here I just need to match it, isn't it? So to match it, here you've got, see, if you look at these two graphs, I hope so. It's going to be a little bit tough in figuring out the answer. First, let me deal with the C and then the D stuff. Okay. Once I match it accordingly with the 1, 2, 3, and 4, obviously these two stuff will be easy to match. Okay. Here, if you look at this graph, it is the graph between the displacement and then the time. Okay, X and then the T. What has happened over here is x was linearly increasing. Then how should the velocity be? Velocity has to be constant, obvious, right? And then the displacement was in the positive direction, which means velocity has to be positive. So only thing that is left over here is this one or this one. This is not possible because on the other part of the graph, what has happened is it started decreasing, which means the vehicle was moving forward, then it stopped, and then it started moving backward with some constant velocity, right? Out of the blue, it just stopped suddenly and then it started moving backwards. Therefore, one has to be positive and the other one has to be negative, right? So C should match with 3. Let me check the options over here. C should match with 3. Okay, this is the only possibility over there. Either it should be like B or D, okay? Option 2 or option 4. That is the only stuff that is possible over here. Either it could be 2 or 4 or small b small d. Okay, so that's the possibility. Then let me verify it for the D graph over here. If I do verify it for that one, here with increase in time t, proportionally the displacement x is also increasing, isn't it? Yeah, then obviously this one has to be the only one stuff, which is this velocity has to be positive and it has to be constant. Okay, so D should match with 1. So D has to match with 1. Therefore, option B should be my answer or option 2 should be my answer, right? This one has to be clear. Let me verify it for the A and then the B graph over here. If I have to do verify it for the A and then the B graph, here if you look at the A graph, initially when the time passed, there wasn't any displacement. Then out of the blue, suddenly it started moving with increase in the displacement proportionally. Okay, with increase in time. Okay, so it has to be clear that the velocity has to increase. That is when linearly increase. That is when as the velocity is increasing, initially the distance covered was less, then for that same time the distance covered was more, which means you need to have like acceleration into it. Fine, then obviously the velocity has to change, therefore velocity has to increase. A should match with 2, that is right. Then what should be the case for the B? For the case of B, it is decreasing. Yeah, initially it was at the maximum position, then it started moving backwards. That too, when it was moving backwards at the initial condition, at the initial situation, it was moving with a greater velocity in the negative direction, then it started slowing down, right? So the velocity should have been greater in the negative direction, then the velocities should slow down and it will never reach the origin. That's how the graph seems to look like. Therefore, this should be the best fit for the B, right? So B should match with the 4. Got it? This should be an easy comparison that I've done over here. You shouldn't have any doubt in this question. It has to be clear. Let's move on to the next question, which will be the final one for the session. This question is also statement based, simple one. Let me read the question. Given below are two statements. They have given us two statements, which is statement 1 and then the statement 2. I just need to find which one is correct. Okay. Yeah, here you've got in the light of given statement, choose the correct answer from the options given below. So I just have to figure out which one is right and wrong. Something like the statement 1 is correct, but statement 2 is false. Both are correct, both are false. That's what I need to get over here. Okay, so first I'll have to figure out which one is true, which one is false, or both are true or both are false. That's what I need to get. Statement 1 is area under the velocity time graph gives the distance traveled by the body in a given time. Okay, so this is a word game. Velocity time graph will give you the displacement traveled. Distance is actually a path length. Okay, it's a scalar quantity that doesn't make sense. Therefore, area under the velocity time graph gives you the displacement traveled by the body in a given time. This one is incorrect, obviously. Then with the case of statement 2, you have got area under acceleration time graph is equal to change in velocity of the given time. That's how it is, right? It has to be true because yeah, if you do the integration of the area under the graph, acceleration times the time will give you how far the velocity has increased or decreased, right? So that's an obvious one. Or that you should have been familiar by this time. Area under the acceleration time graph will give you how much amount of velocity has changed in that time interval. Got it? That has to be an easy one. Anyway, you should have known it. So this is the correct one. So statement 2 is correct. Therefore, the option should be statement 1 is correct, but statement 2 is false. No, it has to be other way around. Both are true on option 2 and 3 is also not possible. Option 4 is statement 1 is incorrect. Yeah, but statement 2 is true. Statement 2 is true. That's the correct answer. Option 4 is my answer, right? You should be clear. Simple question. You shouldn't have any doubt on this question, right? So far we have seen around 8 sums. Those sums were related to graphs and then some differential solving and then based on statements. Okay, and then we did see like numerical type question. Okay, so those were the 8 sums that we have seen. So this should be clear. Okay, these are the different pattern sums that I have chosen to teach you. Got it? As I've told you, you have to practice more and more to get different pattern solving, understanding regarding the different pattern of solving that we are doing. Got it? There wouldn't be anything new regarding the concept that you need to know, but you should do a like next level differentiation and different approach to solve sums. That is something that you need to develop. Got it? With this, the video gets completed. Bye.